Hello everyone. Today we have a new example related to work and energy. In this example, it's all about the work done on an object because of a force. So the scenario of the question is, it says there is an object, 5 kg as a mass, on a rough surface. So we can draw a rough surface usually like this if we want to, or zigzaggy part. So that's the rough surface, doesn't matter. Now the friction coefficient of the surface is 0.2. Now the object is moving to the right due to a 100 Newton force. So that's the applied force. It's 100 Newton, the one causing the motion. The object from the diagram or the figure showing it's being displaced or moved 50 meter. Now, the first part of the question asking to calculate the work done by each force acting on the object. So if we go back to our memory from the example related to forces, I can do the free body diagram on this object and I can locate what forces and determine what forces acting on this object. So it's very obvious. The first one is the applied force. Also, we have the normal force. We have the force caused by the gravity or the weight. And also we have the friction force because it says there is a friction, and that will be the kinetic friction force. These are the four forces acting on this object. So to calculate or find how much work done by each one of them, we have to follow the formula of work, which is force times distance cosine the angle between the applied force or the force causing that, or the force we're looking for, times the distance, and theta, that's the one going to be between them. So let's start with the first one. Let's take as an example the normal force. So if I want to calculate how much work done because of the normal force, I'll say, okay, the normal force times the distance times cosine theta. If I look carefully of that this is the normal force which is going upward and the motion of this object is going to the right, and I will notice that theta here is 90 degrees, which means cosine 90 degrees is 0. That means there is no work has been done by the normal force. At the same time, I can apply the same concept on the gravity force. So it's going to be Fg times distance cosine theta. Once again, I have the distance going to the right, that's the distance, and I have the gravity force going downward. Once again, theta is 90 degrees, which means there is again no work has been done by the gravity force. Okay, let's move to the next part, which is the applied force. The work done by the applied force will be the applied force times the distance cosine theta, and if we do the math, I have a 100. Oops, sorry, let's fix this one. And the distance, it's 50, and the angle between the applied force, the one causing the motion, and the distance will be 0 because they are going same direction. So cosine is 0 is 1, and just simple calculation that will give me 5,000 joule is the work done by the applied force. Now let's go and calculate how much work done by the friction force. Well, it's going to be the friction force times the distance times cosine theta. Okay, now again, from our experience about forces and the videos we discussed before related to the forces, I know the friction force is actually, it's the coefficient multiplied by the normal force. And here is the distance, here is the cosine theta. Now once again, the coefficients and the normal force from the free body diagram, it's equal mg. It's going to be equal the gravity force. Here's d is cosine theta. Okay, so now we can just replace values. It's 0.2. The mass is 5. 9.8. Distance is 50. Now, the distance is going to the right. However, the friction force is going to the left. That's going to be the friction force. If I look carefully, I will notice that the angle between them is 180 degrees. So cosine 180 degrees will give me -1. Now let's do the calculation of this one. That will give me a negative 490 joule. That's how much work is done because of the friction force. Okay, now that's part one of the question, is calculating how much work done by each force on the object. Now the next part of the question is to calculate the net work on the object. So simply what I'll do, I will add these 4 works, or the works done by 4 forces to each other, and that will be the net work. So let me delete all this here or erase it. We don't need that. I have the numbers. Okay, I'll put this back. It's an F gravity force. So to calculate how much is the net work, or the work net, it's going to be the work because of the normal force plus the work done by the gravity force plus the work done by the applied force plus the work done due to the friction. 0 plus 0 plus 5,000 is negative 490, and it's just going to be simple. That will give me a 4,510 joule. That will be the work has been done, or the net work done because on that object. Okay, I hope you find this example useful, and see you again with another one.